So we're continuing with our discussion of wide area networking, and we're going to start down the wonderful magical path that is frame relay. Now, even though we know as networking professionals that MPLS is really the order of the day, frame relay is still on the IC&D2 exam even with the recent updates. And to be honest, I know of at least one wide area networking provider that still sells their MPLS offering on top of a frame relay connection. And especially as you go around to older networks, you'll see frame relay in use quite a bit because it is the next logical evolution in wide area networks. And as a result, you young whippersnapper, I had to learn it, and so you're going to have to learn it too. But when it comes down to it, frame relay is a lot more logical than a traditional point-to-point WAN. For example, in traditional point-to-point WANs, you can very quickly end up with a very complex WAN. Now let's go back to our example here. We have our 3 locations connected to our data center in Dallas, Texas. And life is happy and grand. If traffic wants to get from Birmingham to Chicago, it has to come from Birmingham through Dallas out to Chicago. But since all of the servers and everything are in Dallas, the traffic very rarely has to go between the 2 locations. And so you have a pretty straightforward network. You have a large router in Dallas that has 3 serial interfaces, and you have a smaller router in Birmingham, Chicago, and Raleigh having 1 serial interface each. So let's say you add 2 more locations in Sacramento, California, and Philadelphia, Pennsylvania. And at the same time, you decide, I'm going to implement a VoIP network so that we don't have to pay long-distance calls from Philadelphia to Sacramento to Birmingham just to call other locations on our enterprise. So now if you do this, you don't want the voice traffic to have to go from Sacramento to Dallas and then loop back around and go to Chicago, because you're going to use a lot of resources here on the Dallas network, not to mention you're using twice the bandwidth on these WAN circuits. You're taking up bandwidth coming in from Sacramento and then going out to Chicago. Not to mention that if you truly want to have a point-to-point network and you want to fully mesh all of these locations so that you don't overload the Dallas network, you have to put WAN interfaces in Sacramento and Birmingham and Chicago, and you have to order circuits to go from Chicago to Sacramento and Sacramento to Raleigh and Philadelphia to Birmingham, plus the cost of the larger routers because each one of these routers has to have 5 WAN interfaces. So obviously your 26 or 2800 series router probably can't handle all those WAN interfaces, so you have to buy a bigger router. Not to mention if you add another location, you have to go buy another WAN interface for all of these routers, set up routing and point-to-point WAN connections, and it just gets to be a huge mess. And that's why we have frame relay and its next logical evolution, MPLS. Quite simply put, frame relay allows you to have a single WAN connection at each of your locations, and you can connect all of your remote sites through that one WAN connection. So instead of that huge network with all those WAN connections that you saw on the previous slide, here's all of our locations: Dallas, Raleigh, Birmingham, Chicago, Philadelphia, and Sacramento. And instead of paying for those very expensive long-distance T1s or DS3s, you pay for a T1 to connect to a frame relay provider's cloud. And depending on how you have everything configured, the traffic will leave Dallas, enter the frame relay provider's cloud, and just pop out in Philadelphia, or it'll enter in Chicago and pop out in Raleigh. And exactly how all that works, we'll get to over the next few slides. So how do you define how the traffic gets from point A to point B? Obviously, you have to communicate this to the frame relay provider. The frame relay provider has to configure a logical entity inside their network to transport the data from Dallas to Chicago, for example. And those connections are called virtual circuits, and they allow for a greater flexibility in configuration as opposed to the old point-to-point circuits. For example, if you have a connection between Dallas and Chicago, and you want to add a new connection between Chicago and Birmingham, rather than calling a telecommunications company and getting them to run a WAN connection and adding a router at each location, you simply call up your frame relay provider and say, hey, I need a virtual circuit between Chicago and Birmingham. And they tell you, well, that'll be $1,000 to set that up. You say, great, set it up and pay them the $1,000, and they're done in a few weeks or a few days or however long it takes them. And then you configure it up on both ends, and you can send traffic through the frame relay cloud directly between the 2 locations. Now, there are a couple of terms to keep in mind when you're discussing frame relay circuit speeds, because again, even though we have this magical frame relay cloud in the middle, there is still a physical transport to get the data to and from your equipment. And that may be a DS3 or a T1 or a Metro Ethernet or whatever the layer 1 and layer 2 configuration is. it still has speed limitations. The first term is access rate, and that is the speed of the physical interface, or what the interface is clocked at. For example, you could have a T1 that has an access rate of 1.5 megabit, but the committed information rate may be 768K. Now, the difference between the access rate and the committed information rate is the committed information rate is the logical speed which you can send data through a given interface. So even though you have a full T1 and your router sees that full T1 as being 1.5 megabit, your committed information rate may only be 768K. And so if you go above 768K, you may drop traffic between your two locations, and that's obviously not the best idea. So we'll pause here and we'll pick up with our overview of Frame Relay in the next video.